When we try to find the surface area of a triangular prism, it's a little trickier than finding the surface area of a rectangular prism. And that's because with a rectangular prism, it doesn't matter which pair of opposite rectangles we use as our base, because all of our opposites are rectangles. So unless they specifically tell us or the situation requires it, any of those pairs could be our bases. But with a triangular prism, y'all tend to get confused because a lot of times the way they draw a triangular prism isn't like the one we see here, but they'll draw one tipped over on its side like a tent. And so you think that because it's sitting on a rectangle, that it's a rectangular prism. The fact of the matter is, whatever there's two of, only two of, is what we use as our basis. So in this case, if you look at this shape, we have three rectangles. Each of the three sides is a rectangle, but we only have two triangles. Because there's only two triangles, that makes our base a triangle, again, regardless of what it's sitting on. The way they will try to trick you with this is by showing you something that looks like a tent, so I advise you to just be really careful and really vigilant. So for this problem, we're going to find the lateral surface area of our triangular prism. So the first thing that we're going to do, which is the first thing we always do, is redraw the base. It doesn't have to be perfect. It just has to be pretty darn close. We're just trying to get that base, get the information off the 3D shape, because a 3D shape can be confusing, but y'all are pretty solid on 2D shapes. So I've redrawn my base, and I colored it in green. Not the best coloring job, but it'll get the job done. And now I'm going to label it. Now, it's easy for me to pull the 8 and the 6 off of this shape. It's a little bit harder for me to figure out what the third side is. But if you remember, my two bases are congruent. That means they're the same shape and same size. If there's a 10 on the long side of the top triangle, then the long side of the bottom triangle is also a 10. Now, that 10 is also a hypotenuse, and I know that because it's kind of hard to see, but if you look at the top shape, there is a little right angle drawn in it. And if there isn't one on your notes, please draw one now. We're going to draw one in our shape there as well. We're going to cross off all of the numbers that we used, which leaves us only one number left, and that number is our height. So I'm going to write that down as well. Height equals 15, and then I don't have to worry about that number anymore. I'm going to cross off my 3D shape so that I'm not looking at it, because again, the 3D shape can be confusing. At this point, now that we've pulled all the information we need to off of our three-dimensional shape, we're going to go ahead and start solving for the lateral surface area of this problem. So the first thing we need to do is write down our formula. On our formula chart, it says our formula is S equals big P H. The big P stands for, as we talked about a couple days ago, it stands for perimeter of the base. And the height is the height of the prism. Obviously, our standard procedure has been to write down formulas. So we're writing down whatever the formulas are for that. Now, there's no formulas on our formula chart for perimeter. So instead of writing perimeter or writing some formula for it, we're just going to write what we know to do when we find perimeter, which is add the sides. And then obviously the height of the prism is going to be the variable that we use for H. All right. Now, when we write, the next step is going to be to write down what those sides are. So I have 6 plus 8 plus 10, and the height that we wrote down was 15. So my surface area, my 6 plus 8 plus 10 equals 24. 24 times 15 equals 360 square inches, which is our final answer.